Good morning, good afternoon, good evening, wherever you are. Welcome to this SEGGER webinar on how to run your first RTOS application in less than 10 minutes. I'm Axel Wolf, and I'm the Technical Director at SEGGER US, located in the California Bay Area. If you have questions during the webinar, please type them into the questions box, and we will address them either during the webinar or in the Q&A session at the end. So let's get started. All right, so this is the agenda for the next hour or so for this webinar. And we'll start out with just a quick introduction to SEGGER as a company and to our RTOS called AMBO as a product. Then we'll do a real world scenario. We'll have an example on where I can demonstrate one of the main advantages that AMBO offers you. Then we'll switch into a bunch of live demos where we will build and run a AMBO application. And then we'll also do a second demo where we start debugging and analyzing that application as well. And then as a next step, we'll actually look at EmpowerOS, which is SEGGER's platform operating system for embedded systems. And then we'll have a summary, and then we'll see how many questions still remain. In the background, there are my colleagues from the SEGGER headquarters in Germany from the AMBO team, Michael, Martin, and Till. I'd like to thank them for standing by and answering any questions you may have during the webinar. So type them in the questions box, and they will be answered by those experts. All right, so just a quick introduction to SEGGER. We're a global development tools and software company. The headquarters are in Monheim in Germany, that's near Düsseldorf. We also have 2 offices in the United States. One is in Boston, in the Boston area, and one is in Silicon Valley in California, where I'm located. And then we also just recently opened up an office in Shanghai as well. And you will also find our products in the major distribution network, worldwide distribution in the major distributors. I like to show this slide because there's been a lot of consolidation over the last years in the tools, embedded tools arena. A lot of independent tool companies are no longer independent. They've been bought up by other software companies or silicon vendors. And this is just a slide that shows that SEGGER is here to stay and stay independent. We're not planning on being acquired at any time, anytime soon. So we just built a brand new building in 2018. Those are the headquarters in Düsseldorf, and we're continuously growing, and we're in here for the long haul. There are 4 main product categories at SEGGER. One is the embedded software, so that's all the stacks and software that goes onto the embedded target itself. We have a line of debug probes. Those are our J-Link and J-Trace probes. You've probably heard of them or used them before. We have software tools. So those are tools helping to develop and analyze and debug the software. And then we have a line of production programmers, this is our line of flasher programmers for volume production. So overall, we have 28 years of experience with embedded systems and with everything that goes around and goes along with it. So here's just a quick overview on what we have to offer in terms of embedded software. We have the RTOS, which of course is the focus of today's webinar. We also have a file system called mfile. We have lots of stacks and utilities for networking. We also have USB device and USB host stacks. There's other bus systems like Modbus that we support. Obviously, security is a big topic these days. So we have mSecure, that's our digital signature suite, and we have mCrypt, that's our crypto library. We also have our own secure bootloader called mload, and compression software called mcompress. Graphics, of course, is another big topic. More and more applications obviously have a screen. And then these tools on the left, those are the tools that actually go onto the host for development. Embedded Studio is our IDE, Ozone is our debugger, System View is our recording and analysis tool, and then App Wizard is a tool that allows you to create GUIs using MWin. And in the demos, I'll be using Embedded Studio, Ozone, and System View. So you'll get to see those in the demos. All right, then so really quick about MBOSS. So MBOSS is our real-time operating system. It's available in 3 editions. Just the regular MBOSS, then there's an edition that offers MPU support, so memory protection unit. And then we also have MBOSS Safe, that is our version of MBOSS that is certified for functional safety. So there's several aspects of MBOSS that we talk about. One is reliability. So we've been working on MBOSS for more than 28 years because it actually was the very first product, the first commercial product of SEGGER as a company. It's 100% done in Germany, so all the code is written by SEGGER. There's nothing else in there. MBOSS RTOS is 100% MISRA C 2012 compliant. And as I mentioned, MBOSS Safe is also certified for functional safety in accordance with these standards that you see here. It's deployed in billions of devices since it's came out in a large variety of application areas. We have a very strict development process that we follow whenever we make updates. As you can imagine, that is not an easy thing, but our team is very good at that to make sure nothing breaks when you make an update on a product that's such a large deployment base. We like to think that our code quality in MBOSS is outstanding, which is obviously important for a real-time operating system, which is the heart of any application. And we use static code analysis to verify MBOSS extensively. Efficiency is another trait of MBOSS. Since we've been working on it for so long, as you can imagine, 28 years ago, the embedded systems world looked very different. There were 8-bit controllers, maybe some 4-bit controllers, long before 16 and 32-bit controllers. So we've always been very conscious of only using the minimum amount of RAM and ROM. And even though the newer controllers have much more of those, we don't want to waste that, because we think you will always find something you can do with that memory. So if we can save you some memory here and there in the operating system, then you can put that to use in your own application. So the minimum ROM size for the MBOSS kernel is about 1700 bytes. You need about 110 bytes of RAM minimum. And then for every task control block, it's just 36 bytes. So you can make an MBOSS application really, really small and efficient. It's also, because it's so small, it's very, very fast and versatile. So on a Cortex M7, the context switch time is about 245 cycles. So that's very quick to switch context. Over the years, we've implemented extensive low power support. for various architectures. And then we also have tickless support in AMBOs as well. One big other item is availability. So as you will see, AMBOs supports virtually every core and every compiler, and there are currently over 80 AMBOs ports available, and within those there are about over 500 board support packages. So we'll talk about that more, of course, in this webinar later on. And so basically what that means is that you'll find a board support package for AMBOs for all the common eval boards. And even if there's one that's not there yet, we can easily port that for new cores and compilers. And we can also usually develop BSPs for newer boards in a pretty short amount of time. And another, the last big important trait from AMBOs is helping you to get faster to market. So we have high quality documentation. You have complete source code availability. The API of AMBOs is very easy to use and quite powerful. Once you license AMBOs, you get first-class technical support provided by our development team over in headquarters, who also provide training if that's required. If you have a whole team that's getting started, we can give you a personalized product training. There are kernel awareness plugins available for various IDEs, so it's a pretty good chance that the IDE you're using, we have a kernel awareness plugin for AMBOs for that IDE. There are a lot of compile and runtime error checks in there, and that helps you to identify and avoid application errors quickly. And we deliver, or we offer a variety of example applications to help you get started with AMBOs. And then, as I will show you also later, we have two pretty nifty tools called System View and AMBOs View, and those are profiling and analysis tools that are very helpful for developing your AMBOs application. Okay, so that's enough for the introductions. Let's look at a real-world scenario where you have a new project coming up and a certain make and model of an MCU has been chosen, and actually development boards for this MCU have already arrived at your office, either this exact one or the closest match. So chances are that you've already standardized on a certain way of programming or developing your software. So usually your company has standardized on a certain IDE and compiler because you don't want to change that every time. Just not very efficient. So you are bound by that. And an RTOS shall be used for this project. That's one of the requirements. And if you've used an RTOS before, then that's great. Then it's going to be easier. If not, then you have, then of course you have to do a little more homework to bring your team up to speed with what that actually means. So we're not covering in this webinar, not really covering the benefits of using an RTOS versus not using an RTOS. That there's plenty other material around there for that. So but of course, as you probably know, it is very, very beneficial to have an RTOS in your application, just to make sure things run much smoother and more reliable in your product. And of course, you should be producing a proof of concept as soon as possible with an RTOS running on this new platform. So yeah, so what you need is an RTOS port that you're going to be looking for, but it needs to be for the right MCU core. So that's an RX from Renesas or Cortex M or some other MCU core. It needs to be for the right tool chain, basically supporting the IDE and compiler that you're using in your company, for the right device, and ideally for the right board as well. So Not an easy task. You might be able to find an RTOS port for the right MCU core and tool chain, so that might be out there. But finding one that fits all 4 requirements is, yeah, not an easy task. So when we look at the typical development setup, usually you have a computer with Windows, Mac, or Linux, which is your workstation with your IDE and debugger on it. You have some kind of debug probe connected over USB, and then over SWD or JTAG, you're connected to this eval board that's been used for this proof of concept, which has the MCU of choice on it. And obviously, the task is to find an RTOS and get it on there and show something working pretty quickly. And obviously, there are a variety of choices out there when it comes to embedded RTOSs. But obviously, the case that I'm trying to make in this webinar is that AMBOs will be your best choice for that. So let's just look at the system in a little more detail of what you have to deal with here. You have obviously the board itself. You have the core, which in this case, let's say the device that was chosen is an STM32F4. So that means you have your device set, you have your core set, which is an ARM Cortex-M, and then you have a certain compiler that you're using, like we said. That's usually part of your IDE. So the board-specific aspects, those are obviously have to do with clock setup. What kind of memory, external memory is on this board? Is there QSPI? Is there SD-RAM, or is there an SD card? And then obviously there's I/O elements like LEDs and buttons and switches and such. So those need to be taken into account. Then when we look at the device itself, usually those devices have internal flash memory that needs to be initialized and or programmed with your application. So internal RAM, and then obviously a lot of initializations for the peripherals and the clocks on the device itself. The core, of course, also has a huge impact on your project because different cores have different interrupt controllers, different handling of that. You might have MMUs, MPUs, caches, and such on there. So that is all core specific. And then last but not least, the compiler obviously needs to support the architecture of the device or the core and the instruction set. But you also have to worry about calling conventions, memory models, and things like that. And so the challenge is that your software, specifically the RTOS kernel, definitely has to take care of all these aspects of your system here. So let's just take a step back and actually take a look at what an RTOS actually looks like. And in the most basic form, essentially it's a collection of C source files and header files. Okay, and in that raw or generic form, the RTOS source files are not really aware of any of these 4 things that we have to worry about. And so you have to start narrowing that down. And the first step of narrowing that down is usually to look for a port of any given RTOS that basically makes the RTOS source files aware of the core that they're going to be running on and the compiler that's going to be used to compile the code. So from the generic source files, you get a port that is aware of the core and the compiler. So you get those 2 components down. But at this point, the port still has no awareness of what device it's going to be running on, or let alone what board it's going to be running on. So that has to be a second step. So if you look at RTOS ports for MBOS, you can go onto our website to segger.com/MBOS and go to the supported cores compiler tab, and then you have an overview of all the MBOS ports. So in this column here are all the different cores. It's a pretty long list, so I could only squeeze a little bit on there. So all the different cores are in this column, and then the various compilers, IDE's compilers, are in the second column. And then in the third column here, you actually have links to the specific MBOS ports for that particular compiler, for that particular core. And as I mentioned earlier, there's about 80 of those MBOS ports that are available. And you can actually click on any of those and go to the next page. So let's say, just for argument's sake, let's say you are going to use a Cortex-M part, which is that STM32F4 on our board, and then let's say you're using Kyle MDK as your development environment. So you click on that, and then you get another page with more information and download options for that particular port of MBOS. So you have a memory usage information and timing related information on that site, and then a list of all the different board support packages that are available for the different devices and for the different boards that are all part of this particular port. Remember, this port takes care of the compiler and the core, and then inside there is BSPs specifically for the device and specifically for the board that you're going to be using. You will also find actually a port-specific user guide. So not only do we have an overall MBOS manual, we also have, for every one of those ports, we have a specific user manual to help you get started with your particular system. So as you can imagine, that's as many user guides as we have ports. So that's quite a lot of effort there. And then also you can directly download the evaluation version, basically the object code version of MBOS for your particular core and for your particular compiler. So you can, after you download and save that, you unzip it and you get directories. So again, this is the core and the compiler, and you can drill down into those folders, into the board support area, and there you would find the board support packages listed by MCU vendor. So in our example, we're using ST. So you drill down into the ST folder, and there you have all the different devices and all the different boards. So this is where we narrow it down to really the core, compiler, device, and board. And if you click into that folder, you really have a ready-to-run MBOS RTOS project for your specific IDE, for your board and your device that you can immediately run on your target. So essentially, the contents of these board support packages, they contain all the necessary code to run the RTOS on any given specific hardware, and basically also a project for your IDE that you can directly build and run on your hardware, as well as example applications to get you up and running and to demonstrate the usage of the RTOS. So whatever RTOS you pick, you should look for many different BSPs as part of the delivery, because this is really the only way you'll be able to easily run your RTOS on virtually any hardware, and specifically, of course, the one that you are interested in. And we like to think that only MBOS has this kind of a breadth of board support packages with over 500 that we've been putting together over the years. And so we think we are the leading OS in this regard, making it easier for you to get started. Okay, so let's move on from slides to something more practical with some demos. So on my desk here, I have another eval board set up. So let's say earlier in our example we used the STM32, but let's say the device that was chosen was an NXP K66, which is a Cortex M4, and we actually have an in-house eval board for that, which is our Empower board with this K66 on board. So for the demos here, let's assume that's our target platform, and I have my PC here. In this case, it's Windows, but all our tools, majority of our tools also run on Mac and Linux. So if you're using that, it's not a problem either. And I have my J-Link connected to this board over SWD, and I can actually show you live this process that I walked you through earlier. And so essentially, let's switch over to my browser here. Okay, so this is where you would start on the AMBOS page, and under supported cores and compilers, you have here's this AMBOS port overview table that I showed you earlier that lists all the 80 or 80 plus different ports for the different cores and compilers. So you can look for it that way, or you can actually drill down through any of these menus here. So because I know I have an ARM Cortex M device, I can directly look for my port, and I'm also going to use Embedded Studio as the IDE and compiler, which is our IDE, as I mentioned in the beginning. So I'm going to go with the MBOS Cortex M Embedded Studio port. So I'm clicking on that. So this is this page for this particular port. It gives me the information about timing and memory usage. And then here, as I showed you earlier, is all the board support packages that are part of this port, which is quite a lot. And again, I could go to a specific user manual for this port here, and then with this trial version button here, I could download the particular trial. And I don't want to do that live in the webinar, so I have already done that. Just want to show you where you can get that. So once you download that and unzip it, you essentially get this folder here for Cortex M Embedded Studio. And let's look at what's inside here. You have MBOS View, which is a utility I'm going to show you later. You have release notes for MBOS as a complete product, as well as the Cortex M Embedded Studio version. And you have, again, here the overall MBOS manual, as well as the specific user guide for Cortex M and Embedded Studio, basically your core and your compiler. So I can drill down into the board support packages. So in this case, we have a SEGGER board. Well, I could do it two ways. I can do NXP because we have the K66. So actually, no, this is not. I have to go to SEGGER because that's the board. And then here is the Empower board for the K66. So that is my device and board combo. And then here is my project for my IDE for this particular board, for this particular device. So I already have Embedded Studio installed, so I can just double click this. And Embedded Studio opens up. You can, Embedded Studio is free to use for evaluation and for non-commercial purposes. So you can download it and try it out as long as you want. There's no time limits or code size limits. So you can use it under a evaluation license as long as you're not using it for commercial purposes. So you can just accept that. And then so over here is our project. And let's just look at a little bit what's in there. So essentially, all our eval software packages, they have an applications folder, and there's a bunch of, there's always one application that is the default, and then, but there's always a whole range of example projects that are part of it that you can build and run. Then there is the device specific support. So in this case, of course, we need to be aware of the K66 specifics from NXP. Then there's more documentation. Then here is the library for MBOSS. And then there's some SEGGER specific files for RTT and system view. And then there's some setup files. So this is what's in the RTOS port. And I can just go ahead and open this standard example here. So this shows you how to just create two simple tasks with MBOSS, and it shows you how easy it is actually to how simple an MBOSS application can be. Essentially, in your main, we just have to call OS init, which initializes the RTOS. Then we have the hardware initialization that is obviously board specific. It's just like the BSP init, so that initializes the hardware we're running on. And then we're creating two tasks, a high priority task and a low priority task, that are running in different intervals with different priorities. And then we're starting the RTOS, and well, and then from then on we are multitasking, and we are not ever actually, we're not supposed to ever come back here because you don't ever want to return from main. So at this point, you're just, the RTOS takes over and runs your application. And then here we have the code for the two separate tasks we create. So the high priority task and the low priority task. And what we're doing basically is, just for the simple example, just toggling two different LEDs at different frequencies in these tasks. And we can go ahead and directly build this project. So that invokes the compiler that's part of our IDE. So the build is fine. And then we can actually download that into our board. And I have actually the board sitting right here. So when I, as you can see now, I'm sitting at main, and I can start stepping through the code, initializing the hardware, creating the tasks, and then once I'm starting, I'm free running. And on my board, I can see the two LEDs that are blinking. The high priority task is blinking fast, and the lower priority task is blinking slower. So basically, my MBOSS application is already running, and it's running on my hardware, on my device, and I was able to compile it or build it with my compiler or IDE of choice. Okay, so that was one thing. We can actually pause this, and interesting here in Embedded Studio, in the debugger here, I have a threads view where I actually have the I can see the tasks that are running, my high priority tasks, my low priority tasks. You can see how often they've been running, what priority they're at. You can see the stack info, which is really, really helpful because, I mean, there's always a big question: how much stack do you need to allocate to each of these tasks? So right now it's 512 bytes for each of these, but we're only using 144. So if you're testing application and never goes over that, then you can probably reduce the amount of RAM that you need, and you can use that memory some other way. Okay, so that was the first part of the demos, running and building and running the application. So let's go back to PowerPoint. Okay, so we've done that. So the next step, or the next demo I want to show, is actually how to make it easier to debug and analyze once you've got an AMBO application up and running. And for that, we have various tools and utilities available that I want to give you just a quick overview of. Obviously, we have our trace and debug probes for the hardware, but I already mentioned earlier we have Ozone, which is our debugger, Emboss View, and System View, which are real-time analysis and profiling tools, and they can really help you gain important insights and visibility into your application. So let's take a look again live. So what I can do is I can start Ozone, which is our debugger, and with my project, I actually also get a project for Ozone. Let me just go to the right folder here. So back to the board support package for my board, which in this case was the MPower board. So I have a JDebug file here, which is a project file for Ozone. So I can open that. And the nice thing about Ozone is if your device, even if you don't have your trace clock and trace data pins hooked up, or maybe your device doesn't even have that, but if it has a trace buffer, then you can use the trace buffer to actually get some useful instruction trace and code profiling and code profiling and code coverage information out of your target. So if I load this application into Ozone, you can already see I'm sitting at main, just like I did when I was using the debugger in Embedded Studio earlier, but I can already see the instruction history that was executed just going to main, which is mostly the assembly startup and getting things initialized. So I can see exactly the instructions that and the code that was executed getting there. And I can already also see my code profiling and code coverage information filling up. And down here I have my timeline, which is it's a visualization or a visual representation of my call stack. And up here again, I have an RTOS view that will show me my different tasks. So as I'm starting to walk through my code here, you will see the instruction history filling out and the code profiling and code coverage information. So I can step through my code And again, I'm free running on my board. So I'm just basically I'm running the exactly same code, but in a different debugger. And I can actually, let's put a breakpoint in one of the tasks, let's say the high priority task. And of course, as soon as I set the breakpoint, we're hitting that. And the nice thing about having instruction trace available is I can basically now do a backtrace and go back in my instruction trace history and see what was executed before the breakpoint was hit. And you can see that the instruction trace and the code, the source code and the disassembly window, as well as the timeline, they're all in sync. So you get a great visibility into what was actually going on before you hit the breakpoint. And over here in the code profiling, you can use that to find where your application is spending most of its time, and what's your coverage on source code level as well as instruction level. And then over here, as I mentioned, again, I have information about my different tasks, the stack info, and so all of this is great information that makes debugging your application easier. Okay, so that was just a quick look at Ozone. By the way, so here also in the timeline view, you can see which task you're in. So a high priority task, and that gives you nice visibility into your RTOS as well. So let's go. Let's close this, and let's go back to actually get back to Embedded Studio, which is our IDE, because I also want to show you how you run some of these other examples that are part of the port. So again, this was the default one that we built, but you can, as you see, this folder includes all the demos that are excluded from build right now. So I can put this one into here, and then I can use another one. For example, if you, we also have a C++ demo here. So whatever demo you want to run, you just drag that into the application folder. And then this is the code that's going to be built when you rebuild the application. So in this case, here's a C++ version as well of a demo that basically creates two tasks. But this is giving you a starting point on C++. If you are choosing to use C++ for your application. So we just built that, and in this case we're just creating the two tasks and running them. We're not blinking any LEDs, but again, I built the application, I can debug it, or I can start a debug session, I can run it. And I mean, in this case, like I said, we're not looking seeing any LEDs blink, but I want to use this one as another way of showing you another tool, which is System View. So as I mentioned, System View is a code analysis and recording tool. And again, this is a commercial tool, but you can evaluate it for evaluation purposes and non-commercial purposes. You can use it. So what this is doing is We'll see what it's doing. We're going to make sure we are set up okay. So J-Link is our recorder. So this is information that comes through the existing J-Link connection. This is our target controller. And we can actually live see what's going on in our application as it is running. All the different events I can trigger on different things. Where's my trigger here? It's hidden somewhere on the other screen. So let's say I want to see, I can trigger on the high priority task whenever the task is running. So, I mean, this is essentially almost like, think of it as an oscilloscope for your application that you can use while it's running. So I can see that every millisecond or so, I get a time tick, a system tick, and then every so often that system tick calls the scheduler, and then the scheduler sees what needs to be done, which is any task ready to run. So if the high priority task is ready to run, then the scheduler gives it over to the high priority task, and that runs and goes back to the scheduler, and then it goes back to idle. And you can make sure that in all your different tasks, I mean, this is a very simple example, but if you have like 10, 12 tasks, you can make sure that the timing is all right. You can make sure that you don't have too many deviations in terms of how often these tasks are called. Over here, you have an indication of the CPU load. So we can see the white space is idle, so we see we have lots of CPU load left. And then System View also gives you a lot of system information over here, how fast everything is running, cycle period, some other analysis. And you can see, I mean, we are running live, so you can all do this while the application is running. Here's some more profiling information down here about the different tasks, how often they're called, and so on and so forth. And again, it's a recording tool, so you can stop the recording at any time, and then all this information gets saved, and you can save it and look at it, analyze it later offline as well. So System View is a very, very useful tool for developing not only emboss, but any kind of application, but especially if you have a real-time operating system with a lot of different tasks, and your interrupts are shown. Any type of event you can have recorded and analyzed by System View. Okay, so that was System View demo. So let's see how we're doing time-wise. I need to start wrapping things up. So let's go back to our IDE over here, Embedded Studio. So currently we're still running this example. We're going to stop that. Just want to run one more example. So put this back into here. And there is the semaphore example. So again, there's a lot of examples here that deal with elements of RTOS, like mutexes, software timers, semaphores, so you can learn about how emboss works. And let's build this one here, because I just want to show you just one more example of our tools, which is Emboss View. So we can run this particular example, which is making use of a semaphore. And it's just having a quick example of 5 students sharing 3 separate study rooms. And so obviously there can only be one student in one room at any time. And so this is just a little example that shows you how to can control that with using a semaphore. And I can actually go back to my example here, and I can start AMBO's views. AMBO's view is another nice utility that you can use while AMBO's is running. And you can see here, it's also information that comes through the existing J-Link debug connection, but it also shows you the different tasks that are running and what their status is. So we have a task for every student, 1, 2, 3, 4, 5, and then you can always at any moment see what their status is, and obviously the status changes based on whether they have to wait or if a room is available. And then over here you can see the CPU load over time for the different tasks. So it just gives you very nice insight into your AMBO's application. Also here you have some system variables that you're tracking. So just another aspect of gaining nice insight into your AMBO's application. So let's close that and close this. All right, so that's pretty much what I wanted to do for demos. And you might say, yeah, that's all very good and nice, but obviously just an RTOS kernel doesn't really help me, because I got all kinds of other things that I need to enable. I have USB ports, I have an Ethernet port, I need to add an SD card. So this is where our Empower OS comes in, because that's pretty much the all-in-one solution that makes use of all of the other middleware components that we have that I showed you earlier. The USB stacks, the networking stacks, compression, file system, security, and all that. I mean, you can buy these a la carte, essentially these different components, or if you have a system that needs most of it, this is where Empower OS comes in. You basically buy the all-you-can-eat menu, and all these components are included in that in source code form. So let's just take a really quick look at that. So go back to my browser, which is here. So and we also have, you can evaluate the Empower OS as well. You can go to Products, Evaluate Our Software, and then in this case we have NXP, and then we have the Empower board. So if you drill down that way, then here is basically a eval software package for the Empower OS that not just only has the AMBO's RTOS kernel, but it has all these other components in it, and you can evaluate all these other components in. So basically, these packages are in library form or object code, obviously. Empower OS itself is in source, but you can use these eval software packages to evaluate Empower OS on your platform. I mean, we don't quite have as many of these eval software packages as we have BSPs, but we still have quite a lot. So if you download this AMBO's or Empower OS eval software package, then essentially you get this folder, and here is also again a project for your board for your compiler. So let me start that. And as you can see, again in the overview here, Now we not only have the various OS examples. Now we have example applications for that deal with crypto, compression, our graphics library, IoT, security, USB, Ethernet. So you have examples in there for all of it. So just wanted to make you aware that that is basically then the next step is you can use Empower OS to basically power your whole embedded application, not just using the kernel, but making use of all the other aspects as well. All right, so we are coming up to the end here. So just a quick summary. Should have updated that. So 28 years of continuous development for MBOS, deployed in lots and lots of devices around the world in different areas. I hope I was able to show you that it's available for all popular cores, compilers, and development tools. We saw all the different board support packages for all the popular devices. It has really high performance, but still is very modest in terms of the amount of memory it needs. We have cycle accurate system time. It's also certified for the Made for STM32, which is a program that they started a little while ago. I also mentioned that if you need a safety certified version, we have AMBO Safe, certified to IEC 61508 and 62304. And then basically we have Empower OS as the next step. If you want to go beyond the kernel, that's our complete operating system for embedded systems and IoT device development. And so additional resources, obviously you can go to our web pages. There's good information there. I mentioned the user guide, which is available as a PDF as well as just online, which is sometimes easy to view. I mentioned the different port-specific guides. Obviously, there's one for every of the 80+ ports. We also have a wiki page on MBOS that has some nice information. And particularly one is interesting is if you feel like migrating from FreeRTOS to MBOS, we have a migration guide there for that. And obviously Empower OS also has a section on our website that you can look at. So with that, I would like to end the webinar. I have not seen any questions. Oh yeah, there were a couple of questions that were answered. So you all saw those, and there's no more open questions. So with that, right on the dot, I would like to close the webinar. Thank you very much for listening in. I hope you found it useful. Thank you very much for my colleagues to answer the questions, and I'll see you on the next SEGGER webinar. Thank you so much. Bye-bye.